So welcome back. Now we have to think about how we can design an NFA for a particular problem to accept a particular string for a particular line. So here is a question, a simple question. Design an NFA which accept the set of all strings over sigma AB, where every string that is accepted by this NFA ends with or contains a substring AB. That is a question. That is, every string in this particular language that is accepted by this particular NFA should contain a substring that is A, B, P. So that's a question. So here also, while designing NFA, it is same like DFA, you have to think about start with the design with the least possible string of this particular language. So here from the question itself you can get the idea that the for every string that is accepted by this NFA must consisting of substring A, B, B. So the least possible string that is accepted by this NFA is A, B, P. That is the least possible string that is accepted by this NFA. Now think about the further possibilities of these strings that should be accepted by this DFA. You have to simply think about that. This portion is marked for a very string that should be accepted by this NFA. Now think about what is the position of this ABB. So it can be in the starting of a string. If ABB is the starting of a string, that can be accepted. That should be accepted by this NFA. Now think about if ABB is the end at the end of the string, that is A, B, B, then A, B. So this can be also accepted by this particular DF. Now further possibility is that ABB is the substring. Before and after there may be several ABB or ABB. So that's another pattern that should be also accepted by this particular NFA. So these are the various possibilities of strings that should be accepted by this DFA. So NFA. Now design the NFA with the transition diagram with this concept, initial concept, that's the least possible string. So I will draw the transition diagram of this NFA is like this. Q0 is my initial state. The least possible string is ABB. So I should design an NFA Q1, that is first alphabet should be A. Now think about next alphabet is B, that is B. It should be Q2. Then if one more B is occurred in the input string, that condition will be satisfied. That is ABB as the substring, means ABB is already included in the string, so that will be the accepting state. So that is the initial least possible string acceptance by the NFA. We have to accept that least possible string ABB with the 4 states Q0, Q1, Q2 and Q3. Now think about the further possibilities. Before ABB or after ABB there can be possibilities of occurring A's and B. For this example, if the string is ending with the ABB, then there is a possibility that there may be many number of A's and B before this particular string. So that can be denoted as A, B. That is before ABB, then there can be possibilities of more than one A's and B's. Now think about the second possibility. After ABB, there can be many number of A's and B. So that can be explained with this transition A, B. So I think that is the end of this particular condition, that is our NFA will accept every string that consisting of a pattern or substring A, B, B. Now, what is the difference? So, like DFA, here also there are several states, several alphabet, etc. But the difference is that you can see that for the Q0 state, for the given input, in the case of DFA, the transition is like this, only one transition. But NFA, in the formal definition, we have seen that there can be 2 raised to Q for the NFA. That's much possible transition for the NFA. So that can be understood from this particular NFA. You can see that for the state Q0, you can see that there are, for this input alphabet A, there are 2 possibilities. Means either Q0 with the A can be remain in Q0, or it can be changed its state from Q0 to Q1. Means there are 2 possible cases for this particular transition. That is why there can be possibilities. It can be a null, single state, more than one state, up to 2 raised to Q possibilities can be possible in the case of transition of NFA. Now, Q0 B means if only one state is there. Then for the transition of Q1 A, there is no any transition because it is null transition. Then for the state Q1 B, there is Q2 is the transition. Then for the state Q2A, here also there is a null transition. There is no any transition for the input alphabet, but for the DFA there must be some transition, or at least one transition. For the DFA there must be one transition, but in this case there can be null or more than one transition. And for the Q2B, that is Q3, then for the transition Q3 for A and B, that is remains in Q3B, that is remains in the Q3. So that's a transition function of the designed NFA, and you can see that the formal definition of this particular NFA can be written as N is equal to Q sigma transition function Q0 and F. In this case, Q is equal to set Q0, Q1, Q2, Q3. Then sigma is equal to A comma B. Then Q0 is the initial state. In this case, Q0 is the initial state itself. Then final state. In this case, Q3 is the final state. That is also a subset of capital Q, because Q3 is also a part of this capital set of states. Now, transition function we have already described in this particular case. That is for every state. In this case, especially we have to identify that this particular transition diagram is an NFA, because for the Q0 state, for the input alphabet A, there are 2 possibilities. 2 transitions are there, Q0 and Q1. So that's the way we have to draw the transition diagram. If any of the transition nodes containing more than one transition for an input alphabet, then it will be considered as an NFA. So that's an example for an NFA, and how we can design NFA, and how we can write the formal definition of NFA. Thank you.